Alright, we finished one half of the table. Now we're gonna work on the other half. So we're gonna start over here, top right section, and we're gonna cover power of a power. So for power of a power, the law of exponents, or the property, states x to the a power raised by another exponent, in this case to the b power. When you have an exponent inside the parenthesis and outside the parenthesis, what you're going to do is simply x raised to the power of a times b. So when you have an exponent inside a parenthesis and then outside a parenthesis, you're going to multiply or distribute. So let's do two examples. So say you had a number 8 to the second power raised to the 7th power. So it means that the process is 8 to the power of 2 times 7, which will simplify into 8 to the 14th power. Now don't worry about working it out, I'm just explaining how the process works. So there's our answer. Now say you had variables m to the 5th power raised to the 12th power. When you have something like that, it means m to the power of 5 times 12, which means m to the 60th power, and then that will be our answer. So again, when you have an exponent inside the parenthesis while you have another outside the parenthesis, you're just going to multiply. So I did 2 times 7, that's how I got 14. And then I did 5 times 12, that's how I got 60. In the next part, we're going to be talking about power of a product. So I repeat, power of a product. So we're going to be working in this square right here. So the property, the definition of power of a product is when you have x times y, that's the product, raised to the same exponent, which is in this case a, then it simply means x to the a power, y to the a power. So I basically distribute the exponent. Now let me clarify. This is where you have to pay very close attention. My x has an invisible 1. My y has an invisible 1. All I did was distribute my a exponent just to the exponent only. Okay? Just to the exponent only. So let's do some example illustrating this property. So say I had 5m raised to the power of 3. Now, let me rewrite this where the 5 has an invisible 1 exponent and my m also has an invisible 1 exponent. Both of them being raised to the 3rd power. Now this only works if these two bases are multiplying. If it was addition or subtraction in between the 5 and m, then you cannot use this property. So I repeat, if there's a plus or a minus between the 5 and an m, you cannot use this property whatsoever. In this case, it's 5 to the 1 power times m to the 1 power. Now when there's an exponent outside the parenthesis and then exponents inside the parenthesis, so what I'm going to do is I'm going to distribute my 3 to the exponent inside. So it's going to be 5, 1 times to the 3rd, and then m also 1 times to the 3rd. So my final answer will be 5 to the 3rd, m to the 3rd. Now let's say we have another example. Negative 7 g raised to the 4th power. Now remember, my negative 7 and my g has an invisible 1 exponent. So negative 7 to an invisible 1, g to an invisible 1. raised to the 4th power, I'm going to distribute my 4 to the exponents only. So it's going to be negative 7. Now I'll put parentheses because it's a negative 7. 1 times 4. And then my g, also 1 times 4. So my final answer will be negative 7 raised to the power of 4. And then g raised to also to the power of 4. So that's what happened when you have a exponent outside the parenthesis with another exponents inside. I distribute my a to all the exponent inside. Alright, the next part we're going to go over power of a quotient. So we will be working in the 3rd square on this side. Power of a quotient meaning division or a fraction. So when you're working with power of a quotient, you're going to apply this property, this law, where it's x over y raised to the power of a. When that happens, so remember, my x has an invisible 1 exponent inside, and the y has an invisible 1. I'm going to distribute my a just to the exponents only. So when I do that, it will be x 1 times a is just a, and then my y 1 times a is also a. So that's the property for power of quotient, but also I have to declare where y does not equal to 0, because again, we cannot have a 0 in the denominator. Alright, so let's do some examples, some simple examples. So say that we have 3 to the 5th being raised to the 6th power. Now remember, 3 has an invisible 1 exponent, and the 5 has an invisible 1 exponent. So since we have another exponent directly outside the parenthesis, I'm going to do 3 1 times 6 over 5 1 times 6 also. That would simplify to 3 to the 6th power because 1 times 6 over 5 to the 6th power because 1 times 6. That will be our final answer. Don't worry about working out with the numbers. Alright, so say we have variables like u over w. The whole fraction is being raised to the 7th power. Now remember, my u had an invisible 1 and my w has an invisible 1 for the exponent. So it's going to be u, whereas for the exponent, 1 times 7 over w, 1 times 7 also. So in my numerator, it will be u to the 7th power because 1 times 7 over w, 1 times 7 is also 7. And then this is my final answer. Alright, this last part is going to be short. So we will be working in this last square right here. I'm going to write the definition property and then some examples. Now this property is called the zero property. So when you have a base like x raised to the 0 power, it will simply equal to 1. And then I got to declare that x, my base, does not equal to 0. So any bases, regardless if it's a variable or number, that is raised to the 0 power will simply equal to 1. So for example, if I had 2 to the 0 power, it means 1. If I had negative 4 to the 0 power, see how I put parentheses on the whole negative 4? Then it will equal to 1. Had it been, for example, parentheses on the 4 with a negative outside to the 0 power, then it would be negative 1. This is a unique case. See how I had my negative on the outside? The 0 exponent only applies to the number inside. So this one is a special case. Now let's talk about if it had variables. So if it was m to the 0 power, then the answer is 1. If it was u to the 0 power, also 1. So you see how all of these equal to 1 because they were raised to the 0 power. Now the only special case I talked about was this, is when you have a negative outside the parenthesis, then in that case it equals to -1. But this is a unique case where here the 0 only applied to the 4, that the answer became 1, and then I distribute the negative.